Okay, this is Unit 3, Lesson 2. We're going to get into what's called functions and relations, which is a broader definition. But yeah, this might be kind of new to you, but don't mistake new as too difficult. If you pay attention, it's really not a super difficult idea. There's a few little details you got to remember, but nothing that you guys can't handle. So first off, our learning targets. I can represent relations in a variety of ways. So we got to talk about what a relation is. I can identify domain and range. Okay, so there's a second and a third new word, but also, again, definition's not too difficult on that. And then I can differentiate between a relation and a function. So maybe you've heard of a function, but what's the difference between a relation and a function? So just to give you a preview, like here's all the relations, here are all the functions. Okay, so we got relations are a big group, functions are a more specific group of relations. So every function is a relation, but not every relation is a function. Okay, so first off, a relation is a set of ordered pairs or coordinates. Okay, so just a set of ordered pairs or coordinates, so it relates one group to another, basically. Think of it that way. Relations can be shown in a variety of ways. You can list them as ordered pairs, which would be like this right here, would be number one would be a version of ordered pairs. We could do it as a graph, which would be down here like number 3. Here's a graph. We could also do as a table. Okay, so a table would be like number 2 down here. And then the last one would be a mapping diagram. Okay, and a mapping diagram is going to be on the back. We'll show you one of those in the back. So just very simple here. Domain, range, we got 2 new vocab words, or maybe new, maybe they're not new to you. But the domain is simply a really fancy word for the x values. Okay, the x values, or in other words, the inputs. Okay, and then the range are the y values, or the outputs. Okay, so very simple. So let's look at some examples here. This is writing domain and range, and so right here we've got ordered pairs, and all this says is -3 is mapped to 4, 2 is mapped to 7, 6 is mapped to -1, and 4 is mapped to -1 also. So the domain on this are the x values. Remember, these are ordered pairs, so all the first coordinates are the x values. So x, x, all these guys. So -3, 2, 6, and 4. I'm not super concerned that you put them in order from least to greatest. Don't worry about that. Not a big deal. And then we just put these, see these symbols here? That means it's a set notation. Like here's a set of numbers. Now the range then, on the other hand, are the y values. Notice -1 is listed twice. So you don't have to list it in there. If it's in here twice, we only put it once in the range. So -3 is a member of the range. 4 is a member of the range. 7, and then -1. So 4, 7, and -1 are in there. We don't need to list it twice. So when a domain or range value is repeated, we only need to list that repeated value once. Okay, so we only put that in there one time to say that it's in there. It's in the set. -1 is. It's here, and that's it. We don't have to list it twice. When given a table of values like this, we got x values and y values. We got x and y values. So the domain on this would be 2, 3, 1, and 3. Well, we don't need to list it again, so it just stopped right there. And then the y values, 84, 99, 70, and 92. Okay, Okay, again, these symbols just mean that it's a set of numbers. Here's a group that represent the range. And now a graph, we got a graph here. The domain are all the x values. So this coordinate right here would be -3, 2. So the -3 would be in the domain. That 2 will be in the range. The next one is -2, 1. -2, 1. This point right here would be 0, -1. So 0, -1. Again, x values, y values. Here I've got 3, 0. And then I got 3, 2. Well, 3 is already in there, and 2 is already in there. So I would not need to repeat those values again. Okay. So there's the domain and range. So those were just relations. Okay, so the front side, we're just talking about relations, mapping one number to another number. Nothing totally brand new yet. But now on the back side, we're going to talk about functions. So a function is a more specific kind. So a function, it is a relation, first off. It's a relation that assigns exactly one value in the range to each value in the domain. So in other words, a function is a relation in which the domain does not, I'll run out of room here, does not have two different outputs. Okay, so if a number in the domain is mapped to a number in the range, it has to be mapped to that same number every time. So if 2 goes to 3, and then later on 2 shows up again, it needs to be mapped to 3. Okay. Now there's this thing called a vertical line test that if you have a graph, it makes it real easy. You don't have to really think about numbers, you just look at it and you can figure out if it's a function or not. So it's a test used to determine if a relation is a function. Okay, so if any vertical line passes through more than one point in the relation is not a function. So if you can draw a vertical line and you hit two coordinates, two points on the line, it's not a function. So looking at this first one here, if I start drawing vertical lines, I hit it once. Here I hit it no times. Once. Again, if I drew it here, no times. One time. But right there, I hit it twice. Here's a vertical line that hits it twice. So it does not pass a vertical line test. So tell whether or not the relation is a function. Not a function. Okay, and the reason why this x value, 3 gets mapped to 0 and to 2. 3, 0, 3, 2. 3 gets mapped to 2, 3 gets mapped to 0. So if I told you in this function, I said input 3, you don't know what the output is. Is it 2 or is it 0? You don't know. So this is a situation like if you went to a grocery store, say Kroger, Meijer, Walmart, whatever, and you buy an item, that's the input, they ring it up, the output would be the price. Well, if someone behind you buys the exact same item and it rings up a different price, that's a problem. Okay, so that's not predictable. So that would not be a function. But it would be okay if we look at this point right here. We've got -3, 2. These 2 points have the same y output, but it's different inputs. This would be like buying one item that costs $2 and then you buy a different item that the output's $2. That's okay. It's okay for 2 items to have the same output, but it's not okay for the same item to have 2 outputs. Okay, so that's the difference between being a function and not being a function. So on this one, it's not a function. 3 has 2 outputs. You could also say doesn't pass vertical line test. Okay, so it does not pass a vertical line test. Number 2, can I draw a vertical line and hit it twice? Remember, this being a circle means every single point on here represents an ordered pair. Well, right here, I could draw a line, I hit it once. So that's fine. But here or here or here, any of these hit it 2 times. So not a function. And we could even say, instead of saying doesn't pass, we could say fail vertical line test. The fastest way to write it. Number 3. Can I draw a line that hits it twice? And this one, it looks like I may be able to, but there's no line anywhere that hits this line twice. No vertical line. Again, put your pen straight up and down. There's no vertical line that hits this twice. Okay, so this is a function. It is a function, and it passes vertical line test. Okay, so it passes the vertical line test. Let's go down now. Number 4. You can't use the vertical line test because it's not a graph. But I can just remember, does any input have 2 different outputs? The same input have 2 different outputs. So 4 gets mapped to 9, -2 gets mapped to -2, 0 gets mapped to 4, -2 gets mapped to 5. I thought I got mapped to -2, so that's a problem. Okay, so it's like an item at a grocery store rings up 2 different prices, so that's not consistent. So this is not a function. -2 has 2 outputs. Okay, and number 5, I've got the input -1 gets mapped to 6, 3 gets mapped to 6. So you might be thinking, uh-oh, something's wrong here. They both got mapped to 6. That's okay. These are 2 different output or 2 different inputs. They're allowed to have the same output. Consider this as like 2 items at a grocery store costing the same price. That's going to happen. If -1 showed up again later down here, -1 got mapped to 7 now, that'd be a problem. But that didn't happen. Okay, so all of these are all different inputs having the same output. That's fine. Okay, so yes, that is a function. We could say all inputs have exactly 1 output. Okay, so all inputs have exactly 1 output. Now, we told you there was a 4th way here. There's a mapping diagram. And we'll have you create your own mapping diagrams for these. So there's more than 1 right answer, but there's also a lot of wrong answers. So you do have to follow some rules. Okay, so create a mapper diagram for each relation, then decide it's a function. So in here, I'm going to put the domain. So the domain in the range. So the domain here is actually just 2, because 2 repeats itself several times. The range, the y values, are -3, 0, 5, and 12. Now the mapping diagram is you draw a line. So 2 goes to -3, draw a line to -3. 2 goes to 0, draw a line to 0, and so on. So that's a mapping diagram. You draw the arrows in. So is this a function? Well, I have an input that does not have exactly 1 output. It has 4 outputs. So that's no. Okay, so that's not, because 2 gets mapped to multiple answers. Okay, over here, domain would be 7, 2, -1, and 0. The range would be -4, 8, 3, and there's 8 again, so I don't need to write it twice. I can just leave it as 8. So now 7 gets mapped to -4, 2 gets mapped to 8, -1 gets mapped to 3, 0 gets mapped to 8. Okay, so is that okay? Is it okay for 2 different inputs be mapped to the same output? That is okay. So that is a function, because each input has exactly 1 output. These 2 happen to have the same output, but this input has exactly 1 output, this input has exactly 1 output, so it would pass. It would be a function.